Bloody hell, Jenkins, look at the state of you. What have you been up to? You've been up Cherry Lane? I've warned you about that. I'm going to have words with that Miss Lane.
Hey! Have you seen it? Hey! Have you seen it?
Can you guess what it is yet? Hello and welcome to Tweed's Garage, where in this episode we're studying bodywork. Not that kind of bodywork, this kind of bodywork, Riley bodywork. So we're working on the front, I'm going to call this apron or shroud, I don't know. Anyway, it's a panel that goes under the radiator and covers up the front cross member and chassis rails when the bonnet closes down to the side of it like that. So just sort of a bit of a trim panel, closes all the, so you ain't got a big gap you're sitting there looking at. Yeah, I'll tell you about this one in a minute. This needs replacing anyway. So this video is about that. This video is in two parts because also, spoiler, I'll make another panel, not that panel, another panel. But that'll be in the other video. This is aluminium and the other one's made in steel, and we do different things to that. So sit tight, get yourself a cup of tea. It's a long one. That's why it's in two parts, because it would have been a really long one, sort of, you know, Dr. Zhivago long. So yeah, let's go and have a look what we've been up to. That way. No, that way. For other people who haven't seen previous videos, the reason for remaking this panel, it sits below the radiator, and obviously it's had leaks from the radiator over the years. It's rusted it away in places. And they've repaired it, cut pieces out and welded in a new piece here. But obviously at the time it's an old repair. It was gas welded by the look of it, and it had distorted. It pulled this edge from here in like this, so that the mounting holes, you've got mounting holes for the screws here and here and here. This one completely missed the chassis. This sort of crept over the chassis, and look, they've had to grind a bit out to fit round the engine mount, where it sort of come in close around the engine mount. And then this is how it was mounted. They just clamped it to the edge of the chassis. So yeah, it was fairly terrible. So decided to remake this. So I got myself a sheet of aluminium, a couple of sheets of aluminium, and the first thing to do was strip this panel down for bits that I was going to use. So first thing I done was unriveted the remains of the brass hinge. It's only sort of half a hinge. The other half is I suddenly realised was missing later on. Tell you about that later. But yeah, so just drilled the rivets out, save the hinge. So the first thing I wanted to do was try and recreate this bead in the panel on each side, see here and here, and this is in there to allow clearance over the three rivets on the chassis there and there. But there was a couple of things against it. I did attempt it. I tried to make a sort of a die and stamp set for it to put in the hydraulic press. And initially I tried doing it in a bit of MDF, so I sort of bunged a bit of MDF in the milling machine. Yeah, machinists of a certain calibre look away now. Got a 22 radius tungsten carbide router bit for it, popped that in the milling machine. Didn't know whether it would work, but wound the mill up to about just over 3,000 RPM. I think it goes up to three and a half, but she's an old girl, done some service, so once you start getting up towards there, it starts getting a bit noisy. So just dropped it down to where it was comfortable. Wasn't sure if it would work, but actually, yeah, it worked lovely. So we ended up with a nice die to lay our aluminium on, and then with a sort of punch, a rounded punch, try and hammer this this profile through on the aluminium. But what I found was, yeah, the aluminium just, it was hard work, and it sort of work hardened as well as you were hammering it in. And then I just got really frustrated and kept hammering it to try and get it in, see what would happen. And yeah, this split, the top come off, wasn't sturdy enough. But if it did work, I would have maybe done it. I've got some oak as well. I was going to route out some oak, or even, you know, route out a piece of aluminium. I think this would, you know, as long as you took it gently, you'd be able to do it with this. But yeah, it wasn't successful, and we ended up with a panel. Oh, this is after I lost my rag with it, like this. Yeah, Dottie says it sort of, yeah, looks like a maggot, little aluminium maggot. So, so we had to come up with another solution. So I thought what we'd have is 3 Dimples, very similar. I think Bentley's on their front panels, their apron panels, have, you know, stamped in Dimples to go over rivets and stuff like that, and they look good enough. I mean, this is a nice feature, but the other problem I would have had, even if I'd formed this bead, actually tipping the aluminium over very close to the bead would be quite difficult to get a nice straight line. I could see all sorts of disasters happening, and it's sort of dragging in, you know, material from the side of the bead here, you know, not getting a nice clean edge along here. So I had to come up with another solution. So the first thing I had to do was work out what size the Dimples were going to be. They needed to be big enough so that the panel didn't interfere with the rivets when it was sitting on them, and with enough clearance for measurement discrepancies between the 3 of them on each side when I was making the panel, but also not too big so that they went, you know, beyond this edge. So I was able to turn this edge over to add some strength into the panel each side. So grabbed a piece of steel, something that would sort of last long enough to do all 6 Dimples, and then turned a round profile on the end of it, and a bit of a shoulder to act as a stop, and then this the back diameter turned down just enough to fit into the arbors on the hydraulic press. So with the stamp made, I then moved on to make the dies that this would push through. So I made a 2-piece die. The bottom piece of the die with a slightly bigger diameter than the stamp, to allow for the material to form the dome that I was going to press into it. Also needs to mill away the mating face of the die to provide an edge to push the plate up to when I was clamping it, so I'd know it would be in the right position on the edge of the panel. And then I'd need to put some grooves in around the holes so I could locate it on centre, and then a top plate with a whole board in it, just slightly oversized, so that the stamp would push through it, but would locate nicely and, you know, wouldn't float from side to side. So yeah, just a sliding fit. So to the mill. sheet were, yeah, they started off okay, but then when I increased the depth, because I needed the depth to clear the head of the, give enough clearance around it, you know, for discrepancies of position, and the height of the rivets are quite high, so you know you needed a decent bit of clearance around them. But as I started to go, see, this is sort of initial, but you were getting this, can you see this little wart? It would start off really nice, and then you'd get this wart around here, and then if you sort of went even further, you know, they'd just tear out. See, like there, it looks like a nipple. I mean, it looks like a wart. Yeah, so I was scratching my head, and I didn't know what it was at first. I didn't really sort of think about it, and then you go down an illogical route, and I thought it was sort of air getting trapped behind the dimple die and causing this weird distortion. So I drilled a tiny little hole in the middle of it, and then to the side of it, up above it, to act as a little exhaust to let any air pressure out. But that didn't cure it, so kept fiddling around with it. And the thing was, that's not steel. Let's have a look at steel. In steel, it would work lovely. You know, lovely little uniform dimple. And this is sort of practicing, you know, running it up to the edge and then folding the edge over. So this is where we were getting the results I was happy with. But as soon as you went back to the aluminium, yeah, you'd get these horrors. And I decided what it was the as you were pressing it, although the aluminium was fairly soft, as it started to distort, it would work harden. So then you'd get this bit in the middle would start going rock hard and stop bending, and then, you know, then it would just tear out before it had a chance to pull down the rest of the metal around it into the dimple. So yeah, this took us, you know, a couple of days mucking around with this. But what I've done in the end was I re-profiled the dimple die, made it a bit rounder, you know, sort of smooth the profile up on the top, so it wasn't so extreme. Yeah, and then that worked okay. So we're sort of happy with that. So carried on and went and pressed the dimples in the aluminium panel. So with the panel cut out to shape, I moved into the garage and started pressing the dimples on the panel on the hydraulic press. So it's just a case of assembling the die and lining it up with the marks on the panel, so I knew the dimple would be where I wanted it to, clamping it on, putting it in the hydraulic press, putting this stamp in there, and then pressing it in. and that worked great. So I managed to do the front dimples and the rear dimples, but the trouble was I couldn't get the centre ones. I couldn't get the reach on it, because when I sort of had to put the panel, one leg of the panel in the middle of the press to try and get to it, just didn't have enough clearance inside the frame to get the position I wanted to. So brought the panel back into the workshop and then folded in the inner folds that I was going to put on the inside of the panel. So tapped those edges over, flattened them out, and then went back to the press, and that sort of 10mm each side gave me just enough clearance when I moved the panel back into the press to get to the centre dimple on each side. So press those in and job done. So the dimples pressed in and that bit completed, it was time to fold over all the edges. So back into the workshop, I used 2 pieces of flat steel bar clamped in the vise, and popped the aluminium between the steel bars, using that as my straight edge to bend the alley over. And then it was just a case of, you know, with a block of wood and a hammer, gently tapping the fold over, getting it to 90 degrees, and then taking it out and on the bench, tapping the rest over with a panel beating hammer, sort of tapping it down flat against the panel to finish the fold. So done that on both sides. There's a couple of smaller ones on the inner edges beyond the engine mount clearance cutouts, and tipped over the front edge. And then with that done, that was the basic shape of the panel sorted. So just placed it in position and then marked out my clearances around the engine mounts, and took out the excess material and filed them to shape so that the plate sat nicely on the chassis, and cleared the engine mounts. And finally being able to fix its final position, I then marked through the fixing holes in the chassis through to the panel, and drilled the holes through for the securing screws for later on when I bolted the panel to the chassis. Then all that was left to do on the panel was to flip it over, and with an angle grinder cut out the excess material just above each dimple where the folded metal was covering part of the dimple, and using a finger sander to profile it and round it all off so that wouldn't interfere with the rivets that it was meant to be clearing. And there it was, a new apron panel finished.
refreshments, folks. Go right this second to get something good to eat and drink to enjoy now or during the rest of the show. The finest quality ingredients are in the fixins of the delicious foods you'll find waiting to tempt your appetite at the snack bar.
So what I needed to do then was I needed to reattach the hinge to the front of it. So marked out positions of the new holes that I wanted to put through to rivet the hinge bracket to it. The original hinge plate didn't have too many rivets through it, so yeah, just decided to sort of equally space them and put a few more in just to sort of secure it nicely. I was going to use dome head rivets, aluminium dome head rivets, but I found when I was sort of trying out a bit of riveting on test pieces, it was very easy to mark the aluminium sheet underneath with the snap and die for the rivets. So I decided to go down the route of using pop rivets. I've got some smallish pop rivets about the same size as the dome rivets, so that's what I made my hole sizes for. Drilled those holes, then positioned the hinge where I wanted it to go and spotted through a couple of the holes, drilled those, and then once they were drilled it allowed me to secure the hinge to the panel with the skin grips. What skin grips, I hear you ask? Well, they're these. So these are skin grips. They come in sort of different types and different sizes. So there's different sizes for different size rivets. These ones have the sizes marked on them. I think these are 1/8 of an inch. Slightly bigger ones are sort of 4 millimeters, 532. And we've got even bigger ones here. What are these? 3/16. Like these sort of jumbo ones here. These ones I know from sort of the avionics world, use them for aircraft skin repairs and that, and they're really useful. So they sort of they'll go through the whole size of the rivet you want to put into your material, and they sort of pull up and clamp the two skins together whilst you're working, either for lining up or drilling, you know, lining up and drilling through your extra holes like I've done on the hinge, or just until you get the panel fitted and start putting the rivets in, hold it in place. So they just work. They have sort of one fixed rest. This bit is the fixed rest that rests against the top panel, and then you've got this half rod, sort of half thread rod that goes through it, that's pulled up by doing this knurled nut on the top, or this knurled collar on these ones, and it just pulls up this this middle section rod against the fixed part that's fixed with the rest, and pulls this little foot up on the bottom. I'll show you on a bigger one so you see. Here's a little foot here, this that you can fit through the hole. It'll drop through the hole, but when you straighten it up it will catch on the side of the hole and pull it upwards as you tighten it up, and then clamp the two skins together like that. Yeah, skin grips. The Americans probably call them nipple squeakers or flap tanglers or something, but yeah, I know them as skin grips. So before riveting the brass and the aluminium together, I gave it a coating of this jointing compound, this sort of barium chromate that's used in the avionics industry, and it sort of stops this sort of electrolysis effect between dissimilar metals, and also acts as a bit of a sort of bonding agent as well. So gave it a little coat of that first. So with the hinge secured to the front panel, I then proceeded to go through and drill through all my original holes on the panel through the brass hinge to get all the correct location, and then put a couple more skin grips in to hold it all in place, and gradually went through all the other holes, placing rivets in them and pop riveting them into place. And then once I got them secure with the rivets, it was a case of taking out the skin grips and finishing off with the rivets. Now to finish off the rivets, so they don't look like pop rivets, I used a bit of fine body filler and just filled the holes on each of the rivets and sanded it back. And once it's got paint on and that, you hardly know. They just look like mushroom rivets. So handy little tip if you can't access the back of a panel and you want to rivet it and make it look like round head rivets, you can do it with pop rivets. And yeah, fill them, bit of cosmetic work, and you'd never know. So looking at the panel, once it had all its folded edges on the front and the sides and the inner faces, it was fairly sturdy. It was sturdier than the original one, which this one doesn't have a folded edge at the front, so there's quite a lot of flex in it. Although it doesn't really go anywhere, it's sitting on the chassis and the cross member. Yeah, but I also thought it was sort of lacking something. It's just, it's just a flat panel with these two things and nothing else on it. So what I done was slid the new panel under the radiator, drew a line marking out the front profile of the radiator and the sides, and then continuing the line up each side, making sure it was within the bonnet line, and that would give me a guide to run the panel through the bead roller, to put a bit of a profile on it and sort of strengthen the panel a bit more, just add a bit of interest to it. So with that marked out, I popped the bead roller in the vise on the milling machine. So move the vise towards the end of the table, bolted it down, put the bead roller in there, and it gives me more room than it does on the bench, because there's not a lot of room behind the bench to sort of turn a panel around, and yeah, all this gets in your way. But with the milling machine, I've got a lot more floor space around me. You can move the milling table backwards and forwards to give you a bit more flexibility, and also you can raise and lower the height of it, so you can set it at just the height that you want. And so with that set up, I put a new set of rollers in the bead roller. So I proceeded to follow the line I'd made through the bead roller, forming the raised area on the panel, which gave it a little bit of interest. and it just sort of looks a bit better when you look sort of at the front of the car. You can't really see the raised area because it's just under the, in line with the radiator, but when you look from the front, rather than having a gap where the flat panel is, you've got a little raised area, and it almost comes to just under the radiator, so it just closes in that gap and adds a bit of a feature. And also it's sort of a little rain water lip, stop the rain running up and straight down into the chassis, although that doesn't matter. But yeah, puts a bit of shape into it and a bit of interest, and makes the panel a lot more rigid. So it's a new set of rollers I used on the bead roller, but because this video is going to be a bit long on this, and this job making these two panels took me sort of over about three weeks in all to make and paint and put them on, I'm going to split this video into two halves. So in the other half I'll show you improvements I made to the bead roller and what the new rollers are like. So there you go, a new apron panel for the Riley, made out of aluminium so it doesn't corrode. I don't think I said that earlier on in the video. I'd said it before, but I'll say it again. Made it out of aluminium so it doesn't rust away. Now, what I discovered was, working with aluminium, I didn't enjoy it very much. So in the next video, we make a steel panel. Not the panel we just made. We make a new panel that Gladstone didn't have, but I decided he needed it just to improve his looks a bit. And also we'll be covering the improvements on the bead roller, paint disasters, and other things. So yeah, pop back and join us for that. Yeah, give us a little like and subscribe so you don't miss them. I'll see you next time. Anyway, I've got to go and sort out a problem. Yes, Jenkins, pass me the phone. Going to give that Miss Lane a call and give her a piece of my mind for leading you astray. Right, cheerio. Yes, yes. Hello, Miss Lane. Yes. Need to have words with you, my dear. Been up Cherry Lane again? I'm going to have to tell. There will be a part 2 where I'll do the bloody hell, Jenkins, look at the state of you. What have you been doing? Been up run? Going to have a word with that Miss Lane. Yes, leading you excruciatingly. You've been up Cherry Lane? I've warned you about that. I'm going to have to... Going to have a word with that Miss Lane. Yes, leading you